everyone, welcome to EUREKA classes. I am Dharam, your master teacher of science. So today we are going to start our first topic of NCERT science, and this topic comes from our favorite subject, that is physics. Okay, so the name of this topic and chapter is motion. Motion is the very first chapter that we are studying in class 9 physics. Okay, and this is the very first chapter. In NCERT book you can find this chapter as chapter number 8. So it is a very interesting topic and very knowledgeable topic. If you take proper interest, you can find many things to understand and learn from this chapter. So let us start what motion is. First thing, we are going to start what motion is. Motion is the change in position of the body with time. If any body changes its position with respect to time, it is said to be in motion. It means when a body changes its position with respect to time, the body is said to be in motion. Suppose we take an example. If a body A is at a position and after 10 seconds, if it goes to a position at B, so it changes its position with respect to time, it means the body is in motion. So motion can be described in terms of distance or displacement. It is very important term what distance is and what displacement is. Distance is the actual length of the path traveled by the body. What is distance? The question comes, what is distance? Distance is the actual length of the path traveled by the body. Okay, suppose there is a body and it travels 10 meter in north direction and 10 meter in south direction. The total distance covered by the body will be 20 meter. Okay, so I'll take a small example which will correlate between distance and displacement, and it will be very easy for you to understand. So distance, you have understood what distance is. Now we'll understand what is displacement. Okay, displacement, what displacement is? Displacement is the shortest distance covered by the body. It is the shortest distance covered by the body. What is displacement? Displacement is the shortest distance covered by the body. Okay, so take example, your school is 5 kilometers from your home. You are starting your journey from school. You are reaching to the school, coming back to your home. The total distance you have covered is 10 kilometers. How? 5 kilometers to your school and 5 kilometers back from school to your home. But the displacement, if we calculate the displacement, it will be 0. Why it will be 0? Because the difference between the final and initial position will be 0. You have started your journey from your home and now where are you? You are at your home. So the distance, the displacement, if we calculate the displacement is 0. Okay, you might have understood the difference between distance and displacement. One more example I'll give you. Suppose there is a circular path. Okay, circular path, you run. That circular path, the area is 2 kilometers. You run 3 rounds of that circular path. It means the distance you have covered is 6 kilometers, but the displacement will be 0. Why the displacement will be 0? Because the initial and final position, the difference between initial and final position will be 0. Okay, so now you might have understood what is the difference between distance and displacement. Now we'll study about this motion. I have already told you what motion is. Motion generally it is of two types. One is uniform motion and the other is non-uniform motion. What this uniform motion is? If the body travels equal distance in equal interval of time, if a body travels equal distance in equal interval of time, it is said to be uniform motion. And what non-uniform motion is? If a body travels unequal distance in equal interval of time, it is said to be in non-uniform motion. It is very simple and easy. Uniform motion, equal interval of distance, equal distance in equal interval of time, unequal distance in equal interval of time, that is non-uniform motion. Examples of uniform and non-uniform motion. You might have seen a clock. You can see here the example. You might have seen a clock. Everyone's house there is a clock, right? Wall clock, you can say. And the needle of that wall clock, it is moving in uniform motion. It is moving in uniform motion because the distance covered by the needle, you can see the distance covered by the needle is always equal in equal interval of time. Okay, we will take the example of simple pendulum also. In physics lab you might have seen simple pendulum. That is also the example of uniform motion. Okay, and a movement of arrestor and bouncing of a ball is also an example of uniform motion. Okay, bouncing of a ball or movement of many planets and all this is that we can say it is the example of uniform motion. Now we'll see the example of non-uniform motion. Non-uniform motion, we can see suppose a bike is moving and that bike stops somewhere, again it accelerates at time, again its speed is slow and it reaches to a distance, that is uniform non-uniform motion. Okay, now we'll move to our next topic, speed. It is a very important topic, speed. What speed is? Speed of a body is the distance traveled by the body in unit time. Okay, speed of a body is the distance traveled by a body in unit time. What does it mean? Suppose a body travels 10 meter in 1 second. 1 second means unit time. If a body travels 10 meter in 1 second, what is the speed? The speed will be 10 meter per second, exactly. And the formula of speed, you can see here, the formula of speed is equal to distance upon time. Speed is equal to distance upon time, and it is denoted by somewhere in some books you will find it is denoted by V, some books also write as S. So we can say it is denoted by V. V is equal to small s upon t. Small s distance, okay, upon t means time. The SI unit of speed is very important. SI unit of speed is meter per second. SI unit of speed is meter per second. Okay, now we'll see what velocity is. Now velocity means displacement upon time. You can see we'll take an example here of speed. There is a red car. The speed of this red car is 30 meter per second. The red car is at a speed of 30 meter per second and the grey car is at a speed of 40 meter per second. What does it mean? It means in 1 second this red car travels a distance of 30 meter and this grey car, it travels a distance of 40 meter per second. Okay, next we'll see what average speed is. Okay, we'll understand what average speed is. Average speed is the ratio of total distance traveled to the total time taken. Okay, suppose you are going to a place that is 60 km from here. We'll calculate the total distance covered. The total distance will be 60 km and the total time, suppose we take time to travel this distance is 1 hour. So our speed will be, the average speed will be 60 km per hour. Might be possible in between the speed might be high, it might be low, so it depends, but the average speed, that is the total distance upon the total time, that average speed is 60 km per hour. Okay, so now we'll solve an example and with this example it will be clear to you. Suppose how we are calculating the average speed. See the question here, it is given a car travels 85 kilometers from point A to B, then 45 kilometers from point B to C. The total time taken for traveling is 1.3 hours. What is the average speed? So we'll calculate the with the formula. Okay, average speed formula is how much? I have already told the average speed is total distance upon total time. So first we'll calculate the total distance. It is A to B plus B to C. So A to B it is 85 kilometers and B to C it is 45 kilometers. So the total distance covered by it will be 130 kilometers. Total distance we have got and we have the total time that is already given in the question. Okay, the total time is 1.3 hours. So easily we can calculate the average speed. Our average speed will be 130 divided by 1.3. Our answer will be 100 kilometers per hour. Okay, simple. In this way we can solve many other examples. Now we'll try to understand what velocity is. There is very small difference between velocity and speed. One thing we have to understand, speed is a scalar quantity and this velocity is a vector quantity. Okay, what does it mean, scalar and vector? Scalar quantity is having magnitude, it does not have direction, whereas vector quantity is having magnitude as well as direction. Okay, so the velocity will understand the quantity which specifies the direction of the motion and speed is velocity. Okay, velocity of a body is the displacement of the body per unit time. Speed we have studied, it was the distance per unit time. Here it is displacement per unit time. Okay, this point we have to remember. And formula we know, the velocity's formula is displacement upon time. Velocity's formula is displacement upon time. Okay, so since velocity has both magnitude and direction, it is a vector quantity. It is a vector quantity. Okay, now we'll see the example here. If a car is moving in a straight direction and that direction is not verified in which direction it is moving, it means we can calculate the speed. But if the direction is there in north direction, south direction, it means it is velocity that we are talking about. So speed with direction is known as velocity. You can see here, speed with direction is known as velocity. Okay, what average velocity is? Average velocity is the ratio of the total displacement to the total time taken by the body. Okay, in the case of speed we have studied, it was the ratio of displacement distance, and in velocity it is the ratio of total displacement upon total time taken. We'll see here average velocity is, we can also write it as final velocity, initial velocity plus final velocity upon 2. And this initial velocity is u and final velocity is v. It is very important to understand because in further classes we will be using this u and v very frequently. Okay, speed and velocity have the same unit, that is meter per second. Okay, SI unit is same, meter per second. Okay, now see the example here. The question is, if a car changes its speed from 10 meter per second to 20 meter in just 5 seconds, okay, what is the average velocity of the car? So initial velocity we have to write down. Initial velocity is 10 meter per second. Given here in the question, u is equal to 10 meter per second, v is equal to how much? V is equal to 20 meter per second, and time taken to change this velocity is 5 seconds. So we have got u as 10 meter per second, we have got v as 20 meter per second, we have time that is 5 seconds. Now average velocity formula we will use. Average velocity is equal to u plus v upon 2. U plus v, it means 10 plus 20. 10 plus 20 upon 2, that will be 30 upon 2. The average velocity will be 15 meter per second. What will be the average velocity? 15 meter per second. Okay. Now we'll understand what acceleration is. What acceleration is. It is very important to understand acceleration. See, when a body is moving with constant speed, or if a body is moving with constant velocity, the acceleration will be 0. It is not accelerating. So what acceleration is, we'll understand. Acceleration is the rate of change of velocity. It is the rate of change of velocity. When the velocity is changing with respect to time, we say that the body is accelerating. So the formula of acceleration is final velocity minus initial velocity upon t. Okay, so the final velocity is denoted by v, initial velocity is denoted by u, and t is the denotion of time. So a is equal to v minus u upon t. What is the formula of a? Acceleration. A is equal to v minus u upon t. One thing important to note it down, that if the body is changing its velocity, then only the body will have acceleration. Otherwise the body will not have acceleration. If velocity is not changing, the acceleration of the body will be 0. Very important. If the body's velocity is not changing, the acceleration will be 0. And SI unit of acceleration is meter per second square. Meter per second. We'll take an example. You might have seen many examples. If a body is moving with certain speed, okay, and certainly the velocity changes. It means if it changes from 30 meter per second to 60 meter per second, okay, or 30 kilometer per hour to 60 kilometer per hour, what happens? The body is accelerating. If it changes from 60 to 30, it is deaccelerating, and this deacceleration is also known as retardation. And when this retardation takes place, this takes place when a vehicle, if we take the example of vehicle, the brake is applied, it takes place. Now the very important topic, distance time graph, that is coming in our NTSE examination. We will discuss this distance time graph in our next lecture. We will see how the graph is plotted and which type of questions is coming in our NTSE examination. So till now what we have studied, you have to go through, you understand all those topics and try to solve more questions on the given topic that we have discussed. In the next class we will be discussing about all other topics. We will be discussing about many numericals that is coming from this chapter, that is motion. We will be also discussing about the laws of motion and the different equations of motion. Okay, thank you, have a nice day.